Alright, combination circuits. Combination circuits are circuits that have both parallel and series together in one. And they can be a lot of fun, but they're a little bit of a puzzle, which I personally enjoy. Alright, circuit analysis principles. So what do you do when you're looking at a circuit? The total current for the circuit never changes. Okay, so the current coming out here is the current coming in here, or vice versa. It's actually out here, in here. Alright, the potential difference between point A and B is always the same no matter which path you take. So from here to here, the potential difference is always the same. This is another example. A to B. Okay? But really, the point of that one is saying that when you leave the battery, it's the same source. It doesn't matter if you do this or if you do this. Okay? A combination, the total potential drop across all resistors is equal to the potential difference by the battery. So the drop here plus the drop here equals this. And the drop here plus the drop here equals this. And a combination of resistors can be treated as a single resistor for the purpose of analysis. And this is really one of the big key points. What we can do is we can take these two resistors and turn them into one resistor. And that simplifies the circuit down to where you have this one, and then those two become one, and then you have a nice simple series circuit. So, what do I mean? Let's look at an example. Combination resistors can be treated as single resistors for the purpose of analysis. This means we can simplify it down. So let's say, I'm just going to be nice and easy and say each of my resistors equals 2. They could be equal to anything, they could be equal to different things. But I'm just going to say a nice simple thing. Alright, here we have two resistors. We have two resistors in series involved in a parallel circuit. Ay, that's not fun. So, what we can do is simplify it down. Turn these two into one resistor. So the overall resistance R equals, well, it's a series, so we're adding them. 2 plus 2 equals 4. So this part of the circuit now looks like this. We have a 2 and a 4 ohm resistor, a nice, simple, easy parallel. Woo! Now, we got a parallel circuit, but we also still have it in series with this one, so that makes life a little bit more difficult. So what we would do next is simplify this down, and you would have 1 over R equals 1 over 4 plus 1 over 2, which R would equal 4 over 3. Don't forget to inverse it when you're done if you got 3/4. So now this whole part here, let's see. Let's do it in red. This whole part here doesn't exist. It's just one resistor with a resistance of 4/3. And we can simplify this one down until we have the same thing. Now, if you remember, the other one had 2 in series and then they had a parallel, so they're both going to be equal the same thing. So this guy is going to be gone too, and you're going to have a resistor here of 4/3. And now you've got a nice, simple, easy circuit. 2 resistors in series, each 4/3. Series is adding, so 4/3 plus 4/3 equals 8/3. So that whole circuit has a resistance of 8/3 ohms. Okay, so as you saw, the rules for series still hold true. The rules for parallel still hold true. Okay, if you knew the potential difference across this one, then the potential difference across this one you know. Know the potential difference across this one, you know the potential difference across this one. If you know the current going through here, then you know the current going through here, because what goes in must come out. Okay, so it really kind of helps to keep those rules in mind. What's the same where? It helps. Now, each resistor has 10 ohms. The current through R3 is 2. What's the total current? Now let's break it down. This one had let me see, R1 plus R2. Oh, sorry, hold on. These have numbers underneath them, so we'll use their numbers. R4 plus R5, because those are in series, is going to equal 20. The entire thing is in parallel. So 1 over 20 plus 1 over 10 equals 1 over R. So that will come out to be 20 over 3 equals R for both of them, right? Because they're going to be the same. So these even out in this case. Now they may not always be the same, but they are the same in this case. Okay? So each one equals 20 over 3 for a total of, total of 40 over 3. And that equals our total. Now, the current through R3 is 2 amps. So current through R3 is 2. So what is the total current? If R3 is experiencing 2 amps of current, then R2 is experiencing 2 amps of current. So V3 equals I3R3, and V2 equals I2R2. So it equals 2 times 10 and 2 times 10. 20. So both these resistors experience a potential drop of 20. So a total of 40. So this part of the parallel circuit is experiencing 40 volts of potential difference. So this part of the circuit is experiencing 40 because this is the parallel part. Right? So if this guy is experiencing 40, then this guy is experiencing 40. So if you know the voltage for resistor 1, and you know the resistance of resistor 1, you can find the current. So 40 equals I times R1, which is 10. So I1 equals 4. Okay, now this is where that junction rule comes out. Let me erase this and give us a little bit of room to work with. Alright, so this part of the circuit, okay, this entire chunk, all the current must go through there, right? Because this is in series with the rest of the circuit. Okay, this whole chunk, not this chunk, not this chunk, this whole chunk. So if you know the current through this whole thing, then you know the current through the entire circuit. So you know that current through this part is 2, and the current through this part is 4. So I total equals 4 plus 2. So your total current is 6. Now the next question is, what's the potential difference of the battery? So you want V total. Well, you know I total and R total, so you can find V total. 6 times 40 over 3 is 80. That's an 80 volt potential difference. Now, if you didn't know R total, you could solve for this part. You could always find the potential difference drop across this and the potential difference drop across this and add them together. But usually it's easier to deal with Ohm's law when possible. Alright, that's all for your lesson. Good luck on your homework.